In this lecture, I will go through the exercises that I left in the article in previous lecture. So first one is perimeter of rectangle. You probably all know this. 2 times A and 2 times B is the result. So algorithm could look like this. We compute first 2 times A, then we add 2 times B. So if I move to EAXA and then I add to EAXA, it's like doing 2 times A, right? So then all I need to do is add to this 2 times B. But let's say that I don't want to do 2 times B separately, but I want to add it to EAX. So if I just add to EAXB and then do it again, like this, I will get 2 times A plus 2 times B, right? So all I need to do now is to move to A, that is variable in C++, right? Right here. And I want to move there the result, so that is just the EAX register. And this should work, so let's go and check. I got here already these tests, and it is 12, as you can see, and that is correct, I guess. Right. And it is 12, that's correct. So let's move on to second exercise, where we compute area of rectangle. So we need to store A into some register, and then I want to multiply this register with B. So if I do just mul B, let's try this. Then I move to A, that is just variable right here, EAX. Why I do this? Because I return A, right? So I need to store, in the A is actually the result of this function. So, right, let me check. If I run this program again, and if I wait a while, you can see the result, and it is 8, and that is correct. So, yep, that's second function that is incorrect in row. That's pretty good. So, right, there's nothing hard about this. I think you should all get it. Let's move on to third function, and it is once again pretty easy. So what I need to do is move to EAXA, because EAX is the register that we use for computing. So right, that is why I just do all these functions using EAX. And then I need to multiply it by 4. And that's it. Then I just move to await the result. So let me try to run this. And some of you already knew that there was a problem, right? So improper operand type. You cannot just, multiply by some constant. You need to move this constant to some register. So like this, let's say ECX, I move there 4, and then I multiply by this register, because processor cannot work with this constant. It can only work with registers or memory, right? Here we use memory. That is also possible. But if I use here register, it should all work. So if I run this, and it is 12, so let me check. Yeah, Yeah, 12 is correct. So let's move on to fourth, I guess, exercise, where we compute area of square. And that is also pretty simple. So I move to EAXA, and then I need to multiply EAX with A. And I can just do that like this, because mul, the result of mul instruction is stored into EAX, and mul takes EAX, multiplies it by some argument, and then stores it into EAX. So now I have in EAX the result, and I can just move to a EAX register and it should work. So let me test this. If I run it again, it should be 9. So yes, it is 9, as you can see. Pretty good, right? So okay, we go to triangle. So parameter of triangle, once again, pretty simple. We need to compute a plus b plus c. So if I move to EAXA, then I add to EAXB, and then I add to EAXC. In EAX I have a plus b plus c. So all I need to do now is move to a EAX register, and that's it, right? Because I return a. So once again, let me check this, and it should be alright. It should return 9. Right, it is 9. So great. Now let's move on to this one, parameter of triangle 2, where all these sides of triangle have the same length. So it is 3 times the one side. So once again I move to EAXA, then I multiply EAX with 3. But as you already know, I cannot multiply by constant, so I have to move to some register, the constant, and then I can multiply using ECX register. So now in EAX I have stored a times 3, right? So then I just move to a EAX register and it should all work. Let me check. And it should be 12. Okay, and it is 12. I'm on fire today. So right, parameter of triangle 3 is a bit different. There are 2 sides passed into this function. So here's the expression that I need to count. So once again I move to EAXA. Let's compute this right here for the squared function that I do right here, right? Okay, so I move to EAXA, then I multiply EAX with a, then I get a times a, right? And I can do that because I can multiply using memory. Then what I will do is I want to kind of store the result I have right now in EAX. So I store it to ECX, let's say, like this. And now I can rewrite the EAX register. So I can use it to compute B. So I move there B, multiply it by B, and then all I need to do is add to EAX, ECX, because right here I have a times a in EAX, right? You should get it. So then I move a times a to ECX. So I have EAX kind of empty. right? And then I compute b times b using EAX register. So to get to here, I need to add to EAX, which is b times b, the a times a, and that is an ECX register. And I'll do it right this way. So you should get it now. I think you get this. So then I move to this variable because I use it in the C++. So I move to temp, whatever is in EAX register, and I know it is a times a plus b times b. So I move to EAX a, and then I add to EAX b, and then I move to result EAX register, and that is pretty much it. I think this should work. So let me check. Here, uncomment this line and wait for the computer to compile these things. Okay. Loss of data, yeah. And it is 12, and that is correct. So now let's get to the probably most advanced, I think, but it is still pretty easy for me. Right. So if I here move to EAXA, right? Let me compute this first. So I compute a plus b plus c, then I divide it by 2. That is this s, and I will use it to compute this, right? So move to EAXA, then add to EAXB, then add to EAXD, and then I need to move 2 to some register, right? Because I will use it in I will use it in the when dividing, right? And also, since diff is taking number from EAX and EDX, I need to set it to null, right? So then I do diff with ECX. That is pretty simple, right? So I have this right here in EAX, and I have 2 in ECX, so I divide it. No, right now I have in EAXS. So all I need to do now is to compute this beautiful thing right here. Oh, so now let's move to ECX register the S that we already compute in EAX, and right, so we are using this to compute this, right? ECX will be S minus A, and then I multiply EAX, that is S, and I kinda multiply EAX with this, then this, and then this. Okay, so now I need to subtract from ECX, sorry. I need to subtract A. Then I multiply with ECX. Right, so in EAX will be the result. This whole expression will be in EAX. So I multiply it with this. And then I need to kind of get back to a point where at ECX was S. So I will do that by simply adding to ECXA. Then all I need to do is compute this thing and once again multiply it with EAX. So I subtract from ECX B, then I multiply EAX with ECX, and then once again I add to ECXB. So that way I kinda get the s back. And I will do the same with c, right? So I subtract from ECX c, then I multiply EAX with ECX, and then I add to ECX c. Well, actually I don't have to do this right now because I don't use s anymore, right? So that is useless. So right now all I need to do is move the result that I have in EAX to this result variable in C++. So move to result EAX, and this should work. So let me check. This should return 6, so yeah.
This video is part of my Udemy course. If you are interested about it, make sure to go check it out. I'll leave a discount link in the description of this video.